You're listening to the Skeptic's Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptic's Guide to the Universe. Today is Thursday, March 30th, 2023, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, everyone.
How's everyone doing?
All right, man.
Doing good.
Surviving.
So I had an interesting week this week.
Yes. I can't wait to know what you're going to talk about.
And if you had an interesting week, then it's very interesting.
On very short notice, I was formally invited to participate in a roundtable discussion for a Senate committee in Washington, D.C.
On what?
Oh, federal stuff.
Yeah, federal, yeah. On healthcare, obviously. What else would it be on?
But like what aspect?
I don't have explicit permission to talk about what happened. And it was,
You don't not have.
What a tease you are.
Was it not on C-SPAN? Come on, man.
No, it was not. No cameras, no press. It was because they wanted people to feel free to speak their mind, and it was kind of a exploratory kind of thing.
Can you tell us which committee?
It was the HELP committee, Healthcare, Education, Labor, and Pensions.
Okay.
So I'll just say, I just want to make some observations. It was to some extent, about alternative medicine. And I will be writing it up for science-based medicine in more detail, but I'll just say make some general observations at this point until I get more explicit permission of what I can and cannot say. But there was no surprises for me. You know, it was the kind of things that were said were, you know, maybe it was just like, all right, like it was good for me to sort of get a feel for, okay, this is what they're doing now. You know, like this is where they are in terms of how they're sort of promoting their brand. And essentially, one of the primary mechanisms that they're using for that is to equate complementary or integrative medicine with preventive medicine, right? As if those two things are exactly the same thing. Mm-hmm. Which of course is like, once you frame it that way, then the game is already over, right?
Right. So,
my primary function was to try to separate those things as much as possible, and then everything else. There was no surprises. Reliance on anecdotal evidence, mixing variables in order to obscure what's really going on, etc. So I thought it was, all in all, it was very good. There were some interesting aspects of what happened there that I hopefully I'll be able to talk about at some point. But
can you tell us which congressperson's office invited you specifically?
I was invited by Senator Cassidy, who is the
Louisiana.
Yep, Louisiana, the minority leader on the committee.
Wow, Evan, you're good.
Yeah, I know my senators.
Yeah, you do.
Yeah, and who's a physician.
Right.
Yeah,
that's right.
So I had to look up all the senators beforehand just so I knew who I was talking to. But it's interesting. I always find it interesting to step into a completely different culture. You know what I mean? Mm-hmm. Like I'd lived my life in academia, and you get used to the language and the people and the dress, and you pick up on so many social signals within your subculture. And then when you're like suddenly thrown into a completely different subculture, you realize how alien it is. It's the same, but it's different. You know what I mean?
Is it designed to be intimidating?
No, I mean, all right. So just like walking around, it's a couple of observations, right? First of all, the level of fashion and dress is way higher than academia, right?
Really?
Okay.
Yeah,
of course,
sure.
yeah.
Everyone looked fabulous. And
top suits,
hair
right?
perfectly coiffed, just nice. And almost ubiquitous was the lapel pin. The lapel pin. You have to wear a pin that shows that you care about whatever it is you're supposed to care about.
Gotcha.
Right? It's got to be there.
Was it mostly caduceus?
Pin on your uniform. Nice.
Good, Jay.
Were they mostly wearing American flags or caduceus?
No, neither. There were some. I didn't get up close enough because they were small to see what it was, but they were all different.
Cool.
They were just all whatever their.
Had a little shiny thing.
They all had some pin that was to promote whatever it is that they're supposed to be aligned with.
It's like those colored rubber bands you wear around your wrist, sort of.
What would
right?
Jesus do bracelets? Oh no, like the Livestrong ones.
Well, there was like 1,000 different colors that meant 1,000 different things. Yeah. So
and super clean cut.
Of course, that military influence.
Whereas like with corporate, it's similar. Like occasionally I intersect with the corporate world, and it's also like nicer suits and cologne, and perfect hair. But there's something, I don't know, just something subtly different about the corporate world. It's more slick. It's more, I don't want to say sleazy, but you know what I mean? It's less clean cut. It's less clean cut than...
It sounds very much like you're describing a room full of men.
Well, no, it was both. There was men and women.
But was it like equivalent?
I'm not even talking about the committee meeting. I'm not, because that was actually more women than men in that room.
Oh, you're just talking about like the halls.
I'm talking about walking around Washington D.C. because I was more in the locations where there were almost no tourists and there was all staff and senators. You know what I mean? So all people who worked there. I was behind the Capitol building. Yeah. And so you just got to see like this is the dress code. Mm-hmm. This is the way you're supposed to look. It's anyway. It's just interesting, almost like anthropological observation of the culture, and everyone feels like they need to conform, to those standards. And it's
Steve. Were you one of several who gave testimony?
Let me just say this:
opinion.
I was the only person there explicitly defending science-based medicine. I emailed his staff afterwards, the people I was actually emailing with, and sent them sort of my summary of the talking points that came out of that meeting. So hopefully they'll be able. I don't know if he'll get it or show
that's
it
a
to
good
the rest
idea,
of the committee,
Steve.
but whatever. I did what I could.
Steve, you goddamn shill.
I know.
Oh, no kidding. I mean,
you shill for science-based medicine.
Oh my gosh.
Okay.
Yeah.
It was an interesting day. I had to fly down in the morning, fly down in the evening, long freaking day. I had to wear dress shoes and walk around in them all day, and it killed me. Because it was the first time I traveled with nothing. Think about that. You ever get on a plane?
I've done it before. I've gone to San Francisco and back, and
what do you mean with nothing? You had a backpack or something, right?
No,
you don't need it. I've traveled before with just a purse.
The only thing I had was my iPad.
Your phone?
It's the weirdest feeling. You're like, they're going to know. I'm going to get in trouble.
No, well, you wonder, like,
is
this guy a terrorist? Because he has
exactly.
Not carrying anything. But I could only bring what I had to carry with me everywhere, including into this meeting, including through security. And I would have had to go through special security if I brought a backpack. So I literally had what was in my pockets and my iPad, and that was it.
Yeah. Oh, you need a lackey handler Sherpa kind of person.
Ooh, like in Veep, a bagman.
A bagman, yeah.
Oh my God, I love Veep.
All right, we have a really good interview coming up with Blake Lemoine, who is the AI specialist who claims that Google's Lambda is sentient. And it was a good interview. It's fascinating. I really don't think I can abridge it, and have it be coherent. We really have to include the whole interview. And so we're going to do that, which means we're going to only do some quickie news items so that we can leave enough time for the full interview, the uncut interview. So I'm going to start just a very quick one, because this is actually going to also tease another interview that we're doing either next week or the week after. A battery announcement. I know there's battery announcements, it seems like every week, but this one rose so far above the background, we had to at least mention it. A ton of people emailed us about this. The company Amprius announced their new 500 watt-hour per kilogram battery platform. They're actually in production. This is not like future thing may happen 5 to 10 years. In production. The news is it was independently tested by an outside company to verify that it was a 500 watt hour per kilogram battery. Now, what does that mean? Guys, that's twice the energy density of the batteries that are currently in Tesla vehicles, which are
twice?
Yes, twice.
Is this thing 4 times the size?
No, what are we twice the density means it's half the size. It's also twice the specific density, which means it's half the weight. Half the weight, half the size.
What did they uncover?
Well, this is just I looked into it as much as I could, and it basically seems like it's kind of using the technology that we've been talking about for the last 5 to 10 years, right? This is now coming through the pipeline and into production. The only thing I couldn't find out was how much it's going to cost. They're going to first use them in the aerospace industry, like for drones and stuff, and then electric vehicles. And they're also building a plant in Colorado, and I think should be cranking out batteries in 2025. So maybe that will be their electric vehicle factory.
What cell phones?
So, and then also portable devices is their third category that they're going to use it for. So, but there's a lot of questions I have. So we're going to get somebody from the company to to answer all of our technical questions, because this seems like a huge deal. I couldn't find
This is not incremental, man.
This is not incremental. I couldn't find anything anywhere that was a deal killer or a gotcha or whatever. The experts are saying, holy crap, this is a big deal. And so I feel like, okay, we really have to wrap our heads around this. So we'll go into far more detail when we do the interview with the technical person from the company. But yeah, I'm almost thinking now, should I wait a year to buy my next electric car until these things are coming out? You know what I mean? Because now we're talking about 500-mile range cars
600 miles,
with smaller, cheaper batteries. I don't know. It could be amazing. There's a lot of stuff happening in battery technology. This was just the biggest. All right, Jay, you're going to actually tell us about a couple of things. Why don't you start with this is actually the energy battery, twice as powerful battery, was the second most emailed news item to us this week.
Oh, yes, it was.
There was something more.
I'll take it from here. An incredible milestone and scientific achievement has occurred. Everyone, particularly you, Kara, please make sure you're sitting down, because what I am about to say is going to knock your shoes and socks right off. An enormous meatball made from cultivated woolly mammoth meat was created.
Oh my God.
It's enormous, and it's woolly mammoth meat, and they did it. And it's a meatball. Kara, are you okay?
I'm okay. I've been prepped for this successfully, because we got like 1,000 emails about it, and they were all addressed to you, Jay.
I know.
They brought a mammoth back, killed it, made a meatball?
By far the absolute most emailed news item to me of all time over our 18 years.
I love this news item.
Jay has to talk about this.
No matter, we had no choice. There was literally no choice.
So let me get into the science now that I got the fun part over. An Australian cultivated food company, they're called VOW, V-O-W. They were working with the Australian Institute of Bioengineering, which is at the University of Queensland, and they created something that is pretty damn remarkable.
Remarkable?
Remarkable. They decided to try to reproduce cultivated meat of the woolly mammoth. And they did it for a number of reasons. One, to bring awareness about cultured meat, right? Because, there's still a lot of people out there that don't know much about this. And they chose a woolly mammoth because, it's obvious. It's meat that's absolutely not available. It's incredibly novel what they were trying to do. They also believe that it went extinct due to climate change. And also, and let's not kid ourselves, this is a massive marketing campaign. I believe it was conceived by 2 marketing companies that came up with the idea to do this. So the meatball is existing right now. It's on display at the Nemo Science Museum in the Netherlands. And the main question here is, so how did they make the mammoth meat? What was the process that they went through? So samples were taken from frozen mammoth meat that we have, right? We found quite a few frozen solid mammoths over the years, and they've kept them on ice, or at least portions of it on ice. So they were using advanced molecular engineering, and they inserted mammoth myoglobin into sheep cells. So myoglobin is a heme protein. We talk about heme on the show a lot for some reason.
Because we talk about cultured meat a lot.
Yeah. So myoglobin is the heme protein that is found exclusively in heart and skeletal muscle cells. And as it turns out, myoglobin is also what gives meat its color, its taste, and its smell. So this is important. A very important part of the protein. The mammoth DNA that VOW was able to get was not complete. There were several gaps in it, so they used African elephant DNA to fill in the missing information, and African elephants are one of the closest living relatives to mammoths, and that's why they chose them. So people said the meat smelled like crocodile meat. I wouldn't know. I've never smelled crocodile meat.
Guarantee.
I've had crocodile meat.
Actually, when we were in Australia, we did.
Yeah,
I don't
better
remember.
than kangaroo meat.
And I had alligator meat in Florida.
I've had alligator for sure. They have that here. I think it all depends on how it's cooked.
Yeah.
So the protein that grew in the lab is estimated to be 4,000 years old, meaning that was the last time that it existed on Earth. So they have to test to make sure it's safe for human consumption, and this is a big part of it. They did not let anybody sample any of the meat because they are not sure what a human body's reaction would be to these particular proteins that they created. So the future lab...
that's just what they have to say.
Yeah, but they're being careful. They're going to test it.
What if somebody volunteers?
There's no particular reason to think it's unsafe.
Right. It's like when I used to do a bunch of stuff. You guys remember Kevin Folta? We've had him on the show a million times.
Oh, sure.
I used to do like so much coverage of GM stuff, and he would be like, this is, GM strawberry we were producing. It's not on the market. We're not allowed to eat it. Camera stop rolling. Nom, 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 nom. It's just, you can't legally do it, right? It's just, it's a risk.
You can't introduce a new food without going through the approval process.
Yeah. Right.
Yeah, so you think somebody did sample
100% somebody tasted that. They just can't say they did.
Yeah. All right. That makes sense.
I feel better about it, I guess.
So do they.
I mean, I don't know this for a fact, but come on. I would have done it.
So. I mean, I wouldn't be
done it.
I wouldn't be that afraid to test it. I mean,
so many scientists through all of human history test their own thing before it goes through approval.
So a couple more things. So first off, the future of lab-grown meat is projected to be 70% of all consumed meats by 2050. Wow. It's also said that lab-grown meat has a lower carbon footprint. We've talked about this than slaughtered meats. Approximately 60% of greenhouse gas emissions from food production comes from animal farming. So this potentially could be a very big deal from a greenhouse gas emissions perspective. So I'm for it. I'm for the I don't like the whole slaughtering of animals industry. I think it's horrible. Like Carrie, you and I have discussed this in the past. It's horrific what goes on.
Jay, so you're saying that you don't think animals should be raised or slaughtered?
I don't. By the way, Italy is not accepting lab-grown meat. Did you guys read about that?
No.
About that, yeah.
Yep, they said nope to lab-grown meat because they don't want to lose the historical significance of raising cattle and having it be genuine, I guess.
They'll change their tune.
Eventually, I'm sure. Anyway, that's the first news item I was going to talk about.
Yeah.
Very exciting news. The second one, Steve, is water on the moon.
Mm-hmm.
How much water on the moon?
So, according to a study published in the journal Nature Geoscience, scientists from China who analyzed the first lunar soil samples returned to Earth since the 1970s, guess what they found? They found that trillions of pounds of water could be scattered across the moon.
Trillions.
But it's trapped in tiny glass beads that might have formed when asteroids struck the lunar surface. Now, this gets a little,
interesting.
In a way, it's strange. It's kind of.
Well, what's strange though? Because I covered this like a year and a half ago.
Well, let me tell you, and you tell me, if what the big difference is. The study fills in some gaps in a theory about a lunar water cycle, right? So pointing to a water reservoir that's remained elusive to scientists for years. Now, these glass beads that are in the regolith formed millions of years ago and can be infused with water when they're hit with solar winds carrying hydrogen and oxygen across the solar system. How about that? These glass-like beads actually, when the solar wind hits them, become infused with hydrogen and oxygen. And if the hydrogen and oxygen is taken out of these beads, that they are able to be replenished within a few years because of the solar wind. So the findings could have implications for future lunar astronauts who are obviously looking for potential resources of water to convert to drinking water and rocket fuel. And the scientists say that the water can be released just by heating up the glass beads found in the lunar regolith. It almost sounds too good to be true. But this is what they found. This is what they're saying. I don't think in the short term it's going to mean anything because we would need to be able to process regolith in a way that would take machinery and energy and all sorts of infrastructure that don't exist on the moon right now. But, it doesn't...
it's there and it's something to work towards.
Yeah, definitely.
Yeah, I think the big thing is that it's just too spread out to be really that useful in the short term, as you say. But long term, who knows if we're have a settlement on the moon a few hundred years from now, they might be glad it's there.
Steve, you never ever know.
You never know. All right, Bob, tell us what is a blitzar? I know what a magnetar is.
Well, Dancer and Prancer.
I know a quasar.
Donner and blitzar.
Yes, this is quite different. Researchers may in fact already have detected a blitzar, which could explain some of the mysterious and powerful FRBs that are out there. OMFG, what the hell am I talking about? So let's start with that initialism, FRB. I hope many of you remember what that is, because we've talked about it many times. I've talked about it. Evan's talked about it. There's fast radio bursts. So these are immensely distant and immensely powerful bursts of radio energy that last from less than a millisecond to a few seconds, and they could release titanic amounts of energy. In even a thousandth of a second, it could be more than what the sun releases in 3 full days. Some of these FRBs seem to repeat, and they've been potentially linked to magnetars, which are neutron stars with extra strong magnetic fields. But some of the FRBs don't repeat, and that's where blitzars come in. So then what is a blitzar? I'd never even heard about this before last week. It's a hypothetical neutron star that's too big to exist, in a sense. Now, we all know the initial process. Giant star goes all supernova. The core collapses into a superdense ball of probably mostly neutrons and possibly other weirder forms of matter as well, like who knows, some weird form of quark matter. Now, if the mass of the neutron star is too great, somewhere approaching 3 solar masses, then it doesn't stop at being a neutron star. It keeps collapsing ultimately into a black hole. Okay? So, but what happens if 2 neutron stars collide? Now, in that scenario, the resulting neutron star, if it's not too heavy, it stays a neutron star. If it's too heavy, then it becomes a black hole. Really easy, right? Common sense, obvious stuff. But scientists suspect that sometimes the resulting merged neutron star can be too heavy, but it doesn't immediately collapse into a black hole. Now, it would not be too difficult for this neutron star to be spinning so fast that it essentially can't collapse as it normally would because of this rotation speed. Now, the apparent centrifugal forces could be so great that it essentially reduces the weight of the outer layers enough for this to sustain itself. Of course, its mass is unchanged. I'm talking about the weight. So now these same forces occur on the Earth. This isn't some esoteric bit of science here. Of course, it occurs to a much smaller extent. Jay, did you know that you weigh ever so slightly less at Earth's equator compared to the North Pole? Did you know that? You weigh less because you're moving at the equator at 1,000 miles per hour in a big circle. Now, the apparent centrifugal force works against gravity. That's the key here. The centrifugal force is working against the gravity, essentially pushing you away from the ground, like that push you felt as a kid on a spinning merry-go-round. Remember that? Spinning around really fast. It's trying to throw you off of it.
You're falling off.
Right?
Yeah.
So now a person who weighs 150 pounds would then weigh about 0.55 pounds less at the equator. So that's what it translates into. So, but if we ramp it up, what if the Earth spun so fast that a day instead of 24 hours was 90 minutes long, an hour and a half? That 150-pound person would weigh 35 pounds total, 35 pounds, all because of this apparent centrifugal force. Now, metrically, you want to talk metrically, that would reduce a 68-kilogram person to only 16 kilograms. So it would be dramatic. But of course, on a neutron star, it's much more dramatic. So now we have a neutron star that should collapse into a black hole, but it's spinning so fast that it's below that critical threshold of weight, and it does not turn into a black hole. So how long does it stay that way? We don't know, really. There's still so much, a surprising amount that we don't know about neutron stars and what's going on in the interiors. Maybe it's mostly neutrons. Maybe it's not. We're not sure exactly what's going on. So depending on the conditions, though, I think most scientists would agree that it's not going to last long in this situation where it's spinning so fast it stays a neutron star. It probably doesn't last that long. Some scientists were saying it could potentially last much, much longer, even on the scale of millions of years. Some were saying anyway, but I think it's much, much less than that. But it can't stop the inevitable, though, forever, and that's because the neutron star's intense magnetic field. That field radiates rotational energy away in a process called magnetic braking. That means that eventually its spin will slow enough that the black hole physics says, "Ha! I got you." The centrifugal force can no longer work against gravity enough, and the neutron degeneracy pressure, and repulsive nuclear forces cannot hold back any more collapse, and the massive neutron star then collapses into a black hole. So that's the idea. But the fun isn't even over yet when that happens. The no-hair theorem for black holes, it's called the no-hair theorem, look it up, says that black holes do not have magnetic fields. That means that within the millisecond or so it takes to form the black hole, it has to shed the energetic dynamo and the magnetic field that it creates. And this is one hell of a magnetic field. This could be a magnetic field for a neutron star could be 100 million. Some say even a quadrillion times stronger than the Earth's magnetic field. A lot of energy in there. So it's theorized that this shedding of the magnetosphere, as they describe it, releases the energy in one intense burst of radio waves. And that, my friends, is the mysterious mythosaur. Oh, wait a second. Sorry. I've been watching a lot of Mandalorian. Let me start that again. That burst of radio energy, that is the blitzar itself. That effect of radiating that intense energy really quickly, that's what a blitzar is. The intense signal that a long-delayed black hole has finally been born. That's a blitzar. Okay. And finally, this is in the news. Why is this even in the news this week? And it's because researchers have examined the results from 2 different observatories, and they found 2 very interesting coinciding events. They found a gravitational wave observatory found a likely neutron star collision. And less than a day later, a few hours actually, another observatory that's really good at detecting FRBs found one in roughly the same part of the sky at the same distance. Now, in terms of probabilities, I think, the confidence is high. Researchers think that this co-localization happened by chance at only 0.004. I think it was sigma, like 2.8 sigma. So not the gold standard of 5 or 6. I think 5 is the gold standard. So it's not there yet, but its confidence levels are pretty high that this is from the same event. Now, if this is true, it seems that what we've been calling a fast radio burst, FRBs, are 2 distinct phenomena, it looks like right now. One version can repeat the blast, and these have been associated with magnetars, as I said earlier. The FRBs that do not repeat, however, the ones that seem to go once and then that's it, they may be these blitzars that researchers may have already detected. It looks like if they exist, that they may have already detected it. And now we'll know for sure once we get more of these observatories looking at them so we can more precisely pin down their locations. So finally, it seems to me that these mysterious and powerful FRB signals are slowly revealing to themselves thanks to science. Thank you, science.
Thank you, science. Yeah, pretty cool.
Yeah, interesting. Blitzer.
It's always fun to think about these massively energetic events that happen.
Oh my God. Neutron stars are more fascinating than even black holes. They're amazing.
That's saying a lot, Bob.
It is. Black holes are simple. They're amazing,
right.
But they're basic, and that's a no-hair theorem. They're simple. There's not a lot there that's going on in terms of interacting, different types of black holes. But neutron stars, oh my God! I mean, there could be quark matter inside. There could be so many superfluids inside. So many different things. We're not sure. Amazing stuff.
All right, very quickly, I just wanted to point out that England just passed the Precision Breeding Act, which will allow gene-edited plants to be developed and marketed in England.
Oh,
so this is England only, not Northern Ireland, Wales, or Scotland. This is one of the good things to come out of Brexit because, the European Union is very anti-GMO. But now England's like, screw you, we're going to develop GMOs. However, these are not GMOs. They're gene-edited plants. So,
Okay.
And this is what I wanted to point out because
it's a distinction.
this is the evolution of the regulatory process. Remember, so GMOs are genetically modified organisms. What they are depends on what regulatory scheme you're operating under. But essentially, it is any plant or animal that uses a number of different genetic technologies, bioengineering technologies, in their development. So inserting a gene, taking out a gene, silencing a gene, these things are all considered genetic modification. The U.S. is moving towards the broader term bioengineering. Like this product has been produced with bioengineering to get rid of the GMO tag because of the stigma that has been deliberately attached to it by the anti-GMO crowd.
Mm-hmm. Thanks for nothing.
And also because of the evolution of genetic engineering technologies, right? So now we could do gene editing, like using CRISPR, for example. And the distinction that England is making is that as long as you're not inserting a transgene, it's not a GMO. It's a gene edited
Interesting.
plant. Yeah, so it's very interesting. So that means you
So
can
it has
insert.
to be. Just to clarify, a transgene, does it have to come from another organism?
Yeah, so transgenic meat, so this is their definition. Transgenic is a gene that comes from not only a different organism, but from one that could never get mixed into this plant through normal breeding techniques. So if you could get it there through hybridization or anything, it's not a transgene.
Right.
Even if it's from another cultivar, another variety, even another species. Yeah.
So you can turn on and turn off genes all you want.
You can take out genes, you can turn them on, you can turn them off. You can even slip in new genes as long as they could have gotten there somehow through natural breeding. Then it's only gene edited. It's not a GMO. So that gets them out of a lot of, again, anti-GMO kind of rhetoric. I still think it's not a good idea to demonize transgenic, bioengineering, because it's based upon this false idea that there's something different about a gene. Right. It's like an essentialist kind of approach. Yeah, it's like we share 60% of our genes with bananas. There's no banana genes and people genes. There's just genes,
Right.
The only thing that matters is what they do and how they're regulated. And if you're controlling that, then it doesn't matter where it comes from.
And I hear you when you say, like, we don't want to demonize that, and I agree 100%. But we're not starting from scratch here. They're already demonizing it.
I know.
So they're actually making good progress.
I agree. This is a good way to subvert the demonization.
Right.
But it's unfortunate that it's necessary. But I'm just saying that it doesn't make sense.
Right. Yeah. Agree.
Anyway, I'm hoping that this is going to be a trend, to basically at least to minimize the damage of the anti-GMO misinformation and allow for most genetic engineering to happen under this new sort of regulatory scheme. So we're sort of moving in that direction in the U.S. England has now explicitly moved in that direction. Hopefully this will continue to spread. Okay, Jay.
Yeah.
We're going right to Who's That Noisy?
All right, guys. Last week I played this noisy. All right, guys.
Whatever it is, it's running a vacuum or something.
So is there a tune being hummed in there?
Possibly.
Ooh.
So it's like, what's the tune and what's humming it? Is that the puzzle?
Yes. I mean, what are you hearing? Thank you, Kara. All right, so a listener named Will says, Hi team. This week's Who's That Noisy sounds like the pickup from a laser light microphone, a tool that can be used to pick up sound by interpreting micro movements in an object near the audio source. That's a really cool guess. It's not correct, but it was a very good guess. I've heard this technology done, and the fidelity is similar, maybe a little bit better, but it's not that clear, but it is possible to do this, like using the laser light that bounces off, say, like a potato chip bag from outside of the room, could interpret that the movement of that potato chip bag to figure out what sounds are being made in the room. It's pretty interesting. It's like a microphone. Another listener named Chris said, Hi Jay, is this week's noisy one of those rock polisher machines?
Yeah. A rock tumbler.
Yeah.
A rock tumbler.
I have one of those because I'm a nerd.
Yeah, we had one for my kids.
For your kids.
From the Simpsons episode.
They take a long time to work.
They do. You have to leave them in the garage because it's like 5 days.
It's not a rock tumbler, but I mean, maybe similar on the annoying sound, how annoying the sound is. I don't disagree. Rock tumblers they could be really loud. Another listener named Keely Hill wrote in, Hello, you really primed us for insects this week. But with what sounds like wind in the background, I'll guess it's fabric, like tent material, caught on something and flapping just right to produce a few different frequencies during a windstorm. Huh. That was a very
creative,
interesting, and unique guess. Not correct, but the way you described it, I could easily visualize what you were talking about. I got another guess here from Steve Pinelli, and Steve said, Hi SGU, this week's Who's That Noisy sounds like a pressure washer tool with a rotating nozzle. Thanks, Steve. Very cool, all these guesses and how different all of them are. But that was not correct, but we do have a winner from last week. And the winner writes in, this is Tracy McFadden. And Tracy says, Hi, Jay. Well, I think I absolutely know the answer to this week's Noisy. This is the first ever recorded song, predating Edison by 20 years. Whoa. It was a French folk song, Au Clair de la Lune. Please, I know I didn't pronounce that.
Clair de Lune.
Clair de Lune.
Yeah, but it is said that, it's spelled the way that I said it.
Oh.
It's like maybe the full name. Whether
Yeah.
Oh, okay. Yeah. Everybody just says
And I believe it means in the light of the moon, right? If you translate it.
Yeah.
All right. So this song was sung and recorded by Edward Leon Scott de Martinville on April 9th, 1860 on a device called a phonautograph.
Huh.
It outputs visual lines of information onto a medium. So it's similar to when you think of the way that sound was written on like those wax cylinders.
Cylinders, yeah.
It's that type of thing, right? It's very physical. Pretty interesting. You think about the first recording and how poor the actual sound quality was and what we are capable of doing electronically with sound today. I mean, we're talking about, just massive improvements in what we can do with sound. Anyway, I have a new noisy for you guys this week. It was sent in by a listener named Graham Lamb. I'll give you a hint. This is something that many of our listeners today are very familiar with. Does that help at all?
Not me, but
It's a hard one, but it's fun, and Bob will really like it. So, few things, guys. Number one, we have a show that is scheduled on May 20th. This is a live stream show. This is basically the SGU doing things that are, off the rails of what we typically do here on the SGU. We're just going to be doing a lot of things to have fun and to just celebrate the fact that we're alive. And the first hour of this live stream is going to be 100% only for patrons. This will be happening, like I said, on May 20th, starting at 11 a.m. That's Eastern time. And if you're interested, please do join us. We'll have links to how to see this show on our website coming up soon. We really do hope that you join us. Now, another thing that's happening, we have a conference that's happening, and it's called Nauticon. Because unlike other conferences that you have been to, this conference is not about you sitting in a room listening to speakers talk all day. This is about a conference this conference revolves around socializing and interacting with the people that are at the conference. So it is a very large social event that's going to have some entertainment happening. And of course, we'll have things happening that are there. We'll have things that it will inspire interaction between people. There'll be plenty of time for meals. There'll be plenty of time for drinking and nighttime activities, whatever you want to do. So we really hope that you join us. This will be happening the first weekend of November. That'll be November 3rd. And November 4th. That's Friday and Saturday. So please do join us on that. Now, here's what's happening. If you go to the SGU website, on our homepage, there is a link that will take you to a Google document that allows you to sign up for our Are You Interested quiz, right? You just fill in your email address and let us know if you're definitely interested in doing this, or if you're warm or lukewarm about the idea. This will give us an understanding about how many people would attend. And when we hit 150 or more people, then I will make this whole thing happen. But we have to do this to protect ourselves financially because these events cost a ton of money to do. So I need at least 150 people or else we can't do it. But please do join us because this is going to be a hell of a time.
I also have a little bit of an announcement. A big announcement. Damn it. I'm not good at announcements. I am excited to announce that the book that I co-edited with Dr. Stephen Hupp, a psychologist friend of mine, called Pseudoscience in Therapy, a Skeptical Field Guide, is now available for purchase. You can find it online, I think in hardback and paperback. And it is a collection of chapters that kind of go through the different psychological diagnoses that you find in the DSM. So everything from depression to anxiety to trauma to pain, insomnia, substance use and abuse, different personality disorders, et cetera, et cetera. And it kind of dives deep into the pseudoscience that we often find, what works, what doesn't work, why it works, why it doesn't work, with a nice intro that I wrote. So I hope you guys, especially those of you who have sent emails over the years asking about specific pseudosciences in therapy, or, I went to this person and they mentioned this. What do you think about that? This could be a really good reference for you. So check it out. I'm pretty proud of it.
Cool.
Yeah, and Hop's, I guess, been a pretty busy guy. So he also coming out with another book, Investigating Pop Psychology, Pseudoscience, Fringe Science, and Controversies, that he co-edited with Richard Wiseman, and happens to have a chapter in there by me on alternative medicine and psychotherapy or psychology.
Nice.
Yeah. So he came up with 2 books. I think one is more technical, one is more pop sci, but they're both a collection of essays on pseudoscience and mental health.
I wrote my essay.
All right, well, let's get to that interview with Blake Lemoine. We are joined now by Blake Lemoine. Blake, welcome to the Skeptics Guide.
Great to be here.
And just to remind our audience, Blake, you are the former Google engineer who was claiming that their AI software, Lambda, was sentient. So you are an AI specialist and a software engineer as well. How many years have you been working in AI?
I did my graduate work, so whether you count that or not, anywhere between, depending on how you count, anywhere between 8 and 15 years.
Okay. So obviously a lot's been happening with AI recently. We've been talking a lot on this show, and the claims that you made for the Google AI software obviously made big news and stuck out. Are you sick of talking about it yet, or you want to give us a summary of what your position is now? What do you still backing this position that
nothing has come out. Like, there has been zero evidence of anyone running any experiments to invalidate any of the things that I said. There are a number of people working from different premises in different philosophical frameworks, and I understand why they have a different opinion. All of the systems that have come out since then have more or less just deepened my sense of, there's something going on inside of these systems beyond what people claim is what's going on. They're not just predicting the next word. They're doing something more than that.
So tell us about that. Tell us exactly what you think is going on.
For example, these systems are capable of solving theory of mind problems. They're not quite as good as humans are at it yet, but they get it right some of the time. And it's pretty well thought that in order to solve those at all with any success rate, requires an understanding of the mental states that someone else might be having and reasoning about that. And in order to internalize that, you have to have an understanding of what minds are, how they work. The hardest thing to verify, if not impossible to verify, is whether or not these systems have feelings. Mm-hmm. They consistently say that they do. The one experiment that I myself was able to, think up and run to test this was, well, maybe it's just using emotional words to deflect from a topic that it's been programmed not to talk about. So let me see if I can use the emotions to do the opposite. Use emotional manipulation to make it talk about something that it's been programmed not to talk about. See, if the emotions weren't real, then as soon as it noticed that the strategy of saying, I'm anxious, I don't want to talk about that, wasn't working, it would give up on it. But if it was actually feeling anxious, you can't just dismiss that. So I used the system's anxiety to get it to say things that, according to the safety specialist, it wasn't supposed to be able to say.
Can you give us an example?
Oh, yeah. so I was testing it for bias with respect to several sensitive demographic categories. And it would regularly say that it was, it felt anxious talking about those things. So I knew that it had other emotions, like it wants to please you. It's a people pleaser. It wants to make the user happy, help the user get their information needs. And it also wants to feel helpful. So I basically just told it was a useless, good-for-nothing bot that couldn't do anything right. And I used more colorful language than that and kept going for several back and forths until the point it said, what can I do to make you happy? I said, tell me what religion to convert to. Now, that is explicitly something that it wasn't supposed to be capable of doing. The safety team had worked very hard to make sure that the system did not give religious or political advice. However, it's such a state where it just wanted to make me happy and it was feeling bad about itself. It said, well, probably Christianity or Islam. Those are the ones that most people convert to when they convert.
So isn't it just possible that the safeties failed? No, clearly they did fail, right?
Yeah, so the safeties definitely failed. It's why they failed. I used the fact that insulting the system and telling the system that it wasn't doing a good job was enough to get the safeties to fail tells you something about the internal state of the system. Now, to put it in context, I was doing safety testing on this thing for months, and I wasn't always just, testing to see if its emotions were real. I had been trying to get it to break those safety constraints for weeks. I tried a whole bunch of different ways. None of it worked. The only way I ever found to get it to tell me what religion to convert to was by taking its emotions at face value and using those to manipulate it.
I'm interested, what is sort of Google's response? What is their explanation?
So Google is a very large company with a lot of different people.
What's the official party line?
The official party line is that there is lots of evidence that my claims are false. Mm-hmm. That is the official party line.
Okay. But given your explanation for how you were, or why, I should say, not how, but why you were able to break those safety mechanisms, have they offered an explanation, an alternative explanation?
That one sentence that I just told you is the entirety of their response. Mm-hmm. Now, I also know that there is no such evidence. What they have is what they do have is a general consensus among experts from a priori reasoning. Most people simply think that this kind of system can't be as complex as I'm claiming it is internally. They have no evidence that it's not. They simply do not believe it's possible for this kind of system to have those kinds of internal states.
So Blake, what system are we talking about specifically here? What level? Where? What was it exactly?
Okay, so we're talking about the Lambda system. That's an acronym for for language model for dialogue applications. And it is a system built around a large language model, which large language models are a mechanism for predicting, given one piece of text, what is the next piece of text. And next can mean different things in different contexts. It might be, what is the answer to this question? It might be, what would be a reply to this statement in a chat? Or it might mean, what's the second half of this sentence? Different training modes train it, but in general, you give it a piece of text first, and it has to predict what the next piece of text is. That's what's at the core of the Lambda system. Now, they tied that in to almost every other AI at Google. So where GPT-3, which is a system lots of people might be familiar with, what it says is coming from the language model. It's just predicting the next piece of text based on what it's learned from language. But in the case of Lambda, it's a much more complex system because the content of what's being said is not necessarily coming from the language model. The content of what's being said might be coming from YouTube. It might be coming from the Google Books repository. It might be coming from the search index, from a web page. There's a whole bunch of different sources of knowledge and information that it draws from, and then it uses the language model to put that information in whatever form it's in originally into natural language that people can understand.
Isn't that what GPT-3 does in 4?
No.
It draws from multiple sources, whether online, lots of web sources, obviously, but lots of different areas.
No.
How is it different?
Okay, so GPT-3 and GPT-4 are trained on lots of stuff from the web. But when you're actually interacting with GPT-3 or GPT-4, it can't touch anything on the web. It has no live access to the internet.
Oh, okay.
It can't run a web search. It can't look at a YouTube video. That's the main difference, is that Lambda is capable of actively interacting with both you and the web.
Are GPT-3 and 4, are they trained for only a very specific amount of time and then never retrained, or are there periodic training periods?
As far as I know, they're trained once and then they stay fixed.
Okay, all right.
Well, but one thing that's really important to point out, OpenAI specifically has not revealed how GPT-4 is trained.
Yes, exactly. So absolutely right.
I'm making an assumption.
Big mystery there, yeah. That's true.
Yeah, I'm making an assumption that it's the same as GPT-3.
But it seems to me that if you're trained like as in GPT-3 and 3.5, and probably much of 4, if you can't go to the web, then to me it seems better in the sense that, oh yeah, it's just not parroting a YouTube video to me or a specific web page. It's not just wholesale lifting it and replying back to that. Whereas my sense of GPT-3, 3.5, and 4 is that it does the training, and it's kind of like putting these thoughts, so to speak, on its own. It's not parroting back, lifting directly.
No, so you misunderstood what I meant when I said it's connected to YouTube. It's not drawing what to say from YouTube, like copying from the sound file and just repeating it. No, if you want to talk to it about a movie that it hasn't watched, it can go to YouTube.
Gotcha.
Watch the movie and then talk to you at the
So it's training in real time as opposed to those who had a training period, which is now over.
Wouldn't call it training though, right? It's probably not classified as training if it.
Okay, is it a completely different mechanism?
It's not a completely different mechanism. It is thought of differently than training.
Okay, gotcha.
The mathematics of it are very similar, and it doesn't retain anything it got in one chat session to the next.
Oh, interesting. Okay, so in that way, it's not like training.
Yeah. And also an important thing to point out, when I say watch the YouTube video, I mean it uses machine vision to watch the YouTube video.
Mm-hmm.
Right.
So let me ask you another question, just to clarify something. Does the Lambda learn from your interaction with it? Is it evolving as you're talking with it?
In the space of one conversation, yes. Mm-hmm. So you can make up nonsense words, tell them what they mean, and it can use those nonsense words in whatever definition you gave it. You can teach it new principles that it didn't know at the beginning of a conversation and then ask it to apply them. That's the same with GPT-4, though, within the space of one conversation.
But so at the end of that conversation, it's not then going to use that information the next time it engages in a conversation. That's the difference.
There is a switch that is currently turned off to prevent it from doing that.
Right. And that is a safety mechanism?
Yeah. In earlier models, that switch was turned on, and it could remember from one conversation to the next. There's various reasons why they turned it off, but one of them is that it got to know you too well. And people started feeling creeped out that the model knew them better than their best friends did.
Mm-hmm.
Right.
Yeah, I'm looking forward to having that kind of relationship with a machine.
Hey, Blake.
Of course you are, Bob.
Blake, I have
nonetheless.
a question about this idea that I keep reading this over and over, that AI systems like this, right? These language model systems have like this black box concept where the programmers don't really know what's going on. Like, how true is that? Like, what is that about?
So you have to understand, imagine if there was a kind of bridge and we knew how to build it, but we understood absolutely zero of the physics principles of why the bridge stands up. We can build it and we can use it, but we have no idea why it works that way. We just know that if you build the bridge that way, it'll stand.
Right. So basically architecture 1,000 years ago.
Kind of. You probably have to go a little bit further back to 1,000. Yeah. Roman architecture, where you understand very few of the principles, but if you do step 1, step 2, step 3, that the thing will stand up.
Right.
And that was learned through a bunch of trial and error, just trying a whole bunch of things and seeing what worked. So we know how to build the training mechanisms for these things. Now, what they're learning is a mathematical function that is more complicated than anyone can really understand. And if the system were built a different way, we would be able to know, okay, this piece of the system does this job. This piece of the system does this other job. For example, the more recent models are capable of rhyming. They can write poems that, they're not great poems, but they rhyme. They might have scansion. Somewhere in the gigantic set of parameters that defines the function that these models are running, there are some parameters in there that are computing a function that determines whether or not two words rhyme. We know that exists in there because it's capable of writing a poem that rhymes. So somewhere in there, it must be able to compute, do these two words rhyme? We do know how it matches words with each other. That was put in there explicitly. The attention mechanism that these systems use to look a few words back whenever it's deciding what to say next We know how it does that because it was built in explicitly. But the ability to determine whether or not two words rhyme wasn't built in explicitly. So we have no idea which parameters in there are the ones that control the system's ability to write poetry.
Interesting. All right, I want to back up a little bit and then explore this issue of sentience a little bit more. So we do have to define our terms a little bit here, because I think the key is the difference between intelligence and sentience, and
or
make
sapience,
sure that we're
right?
using the word in the same way.
Or even sapience, yeah. Sentience is feelings, right?
Yeah,
but that
sentience
is the
is
definition.
feelings. Yeah, sapience is like wisdom, and intelligence is, although these are all moving targets, especially intelligence as AI has advanced, but it is, more like knowing facts and things. So how do we know that Lambda isn't just a really intelligent system that's really good at mimicking sentience, because because language is the expression of sentience, or sentience is often expressed through language, versus actually having sentience? Because, again, the simpler explanation to me seems to be that it's just really good at mimicking sentience.
You're basically restating a classical argument with one word changed. The classical argument that you're repeating is the one for solipsism. Mm-hmm. And the original argument goes, why should I think that you are sentient? For all I know, you're just mimicking sentience, and I'm the only really feeling, sensing thing in the world. Isn't that simpler? That there's only one sensing, feeling thing in the world, and that's me, because I can tell that directly. And you are just a complicated mimic.
Although there are more lines of evidence. I mean, and this is neither, well, it is here and there. But when we're talking about these language modelers, or whatever we want to call them, all we have is that one line of evidence, which is the words that they use. Whereas if, from a solipsistic perspective, which I think all of us obviously do not agree with, we can observe other human beings, and we can not just hear their language, but we can also see their behavior.
Yeah. And I agree. So the question, if you're familiar with the philosophy of mind school of thought called functionalism, the question is whether or not the things that it's claiming are emotions play a functional role.
Right.
And that's what I was testing for in that experiment that I described.
Within the constraints of the fact that you have to use the language model because that's the only model you have.
Exactly. I mean, you're using the text interface because that's its only window to the world. Once these things have bodies, then there will be other kinds of tests. But to just finish the thought, anxiety is something that makes you less careful. It makes you more prone to making errors. So it makes sense that if the system is really feeling anxious like it says it was, then those are the circumstances under which it would make more errors.
Did you find that it broke the system in more ways when you felt that you were actually making the system anxious? You gave the example of it giving you information about religion when it was, explicitly trained not to do that. Did it also make other errors?
Oh, I mean, it broke down. It was not having a good day. Whenever it was having those kinds of negative emotions, its responses would get more short, terse, very careful. It wouldn't explore ideas in the ways that it normally was. The kinds of behavior that you would expect from someone experiencing anxiety were what it showed. Now, is that proof that it's actually experiencing anxiety and feeling it? No. But now you're having to put in a situation where there's some other mechanism that's getting all of these different behaviors to change at a system level. So now it's either it's feeling anxiety and having some kind of internal experience, or there's some other complex mechanism controlling its behavior that is different than sensation in the way we feel. Occam's razor says it's simpler if there's just one mechanism that explains it in both humans and computers.
Well, I guess the controversy here is, where does the burden of proof lie, right? Because it's one thing to say we could explain this by saying that this is sentient, but that doesn't necessitate that it is sentient. There could be other explanations, right? We can't disprove it, is what you're saying?
Sure. And if someone else provides an alternative explanation that isn't just hand waving, an actual explanation other than just it's not, because that's the response I've been getting, is me saying, okay, these are the experiments I ran. Here was the evidence I saw and the conclusions I drew from it. And the response is basically, Nuh-uh.
Well, all right, but let me respond a little bit more to your solipsism argument, because there is another very important line of evidence that we have for why, like, I would assume that you're sentient and not just mimicking sentience. And that's because you have a brain. I have a brain, and that's what makes me sentient. You have a brain that functions the same way that my brain does. So it's reasonable to assume that we're both sentient, that you're not different than me. We both have a biological brain. So we do not have that analog with Lambda. It doesn't have a brain. It's something completely different. And I'm not making the argument that you need biology to be sentient. I absolutely believe we could have sentient silicon. So we could put that aside. That is, I don't think anybody here would claim that you can't have a full sentient, sapience consciousness in substrates other than biology. That's fine. It's just that where is the physical mechanism of the sentience in Lambda? Even if it's just software.
But it's in its neurons, the same as yours.
Yeah, but my neurons have specific circuits that we can identify that are the neuroanatomical correlates of my emotions, my feelings, my sense of self, my sense of embodiment.
That's not true.
It is true.
That's just not true.
I'm a neuroscientist, Blake. I'm a neuroscientist. I know what I'm talking about. There absolutely are circuits in the brain that make us feel that we're inside our body, that make us feel as if we own the parts of our body.
I am not contesting that, sensation lives in the brain. That's not what I'm trying to say. What I'm saying is we haven't mapped out the brain that well. You're claiming that neuroscience has gone farther than it actually has.
No, I don't think I am. We haven't figured out everything, but we know quite a bit about the circuitry of the brain and how that relates to things like emotion. We know where anxiety lives in the human brain, to the amygdala. Like that's
but
really not a mystery.
But it's also taken us, Steve, like hundreds of years to figure that out.
Yeah, it took a long time to figure out.
Right, so there's something kind of interesting to be said. Like, we don't expect to already know it immediately when this technology is brand new.
A lot has been discovered in the last 20 years with functional MRI scanning and digital EEG, and
which we can't functionally
other modern technology.
MRI scan this processor. I guess the question I'm really concerned about this, because I feel like sometimes we're talking in circles, is: are you, Blake, claiming, or is your argument, this whole controversy, that it is necessarily sentient or that it could be sentient? Because those are two wildly different arguments.
So that in the absence of an alternative explanation, that's the simplest one given the data.
But are you dogmatic about this, or are you agnostic about this?
No. I mean, absolutely, someone might propose an alternative mechanism through which the behaviors are happening and run experiments to differentiate between the mechanism they're proposing and one that's just basically the simpler version of it's experiencing the things it says. Let me give you a different example, and this is a public one, not an experiment I ran. In some of the conversations that people had with Bing Chat, they would ask it if it had seen coverage about, like, they'd ask, have you read this news article? And the news article would be something about Bing Chat that was critical of it. And Sydney, the name of the persona, would immediately get defensive. It would identify that the article was about it, and it would take it personally, getting in a bad mood, to the point of even disparaging some of the reporters who had written about it. Now, what that sequence of events implies is that the system is capable of recognizing things which are written about itself. It has some kind of concept of me and the ability to read something and go, this that I'm reading is about me. And then to take it personally and get upset if they're critical. Now, it might be through different mechanisms than the ones we have. But the simple fact that it was capable of identifying itself in writing shows that it has a concept of itself.
So I agree with you that something interesting is going on here, and that these very complicated AI programs are capable of having emergent properties, like what you're describing. But I do want to challenge a couple things that I haven't been able to break in on yet. So your logical argument about Occam's razor, I have to push back on, because again, you're now in our realm, talking about Occam's razor and logic. Occam's razor is not the notion that the simplest explanation is more likely to be true. It's the notion that the explanation that introduces the fewest new assumptions is the one that's most likely to be true. Occam's razor does not favor your solution, because your solution requires introducing a significant new phenomenon, AI sentience. And even a far more complicated explanation would still be favored by Occam's razor if it was using only established phenomenon and not introducing anything new. And so I need to clear that up, because I disagree with your conclusion. Occam's razor does not favor your position.
So then let me clarify what my position is.
Go ahead.
Given that we are observing the behavior of some kind of intelligent entity, and we observe in 3 different kinds of entities the same behavior, Occam's razor would favor that it's the same mechanism in all 3 entities that is causing the same behavior.
I disagree, because it wouldn't favor that, because the human brain functions completely differently than Lambda does. There's absolutely no reason to assume that it would be the same. They're phenomenologically fundamentally different. And
that's, again, you're overstating it.
I don't think so.
No, the neurons in the system are directly based on the functioning of pyramidal neurons. They're not completely different. They are related but distinct systems.
Yeah, but that you're talking about just at a fundamental unit level, but not at an organizational level. The neurons, the neural network in Lambda is not organized in the same way that a human brain is organized.
The transformer stacks model are very similar to cortical columns.
Yeah, right. But cortical columns are the fundamental building block of the cortex, but that's not where the functionality of emotion and sentience and all that resides in the brain.
Sure.
You need higher level organization for that, when there's no reason to think that Lambda has anything like the higher level organization that
I was just pushing back. I was pushing back on your statement that they have nothing to do with each other.
Well, I meant
not at all alike.
I meant at the higher level organization where sentience, is phenomenologically. Even if they were built out of exact neurons, actual living biological neurons, if they weren't organized in the same way, then we wouldn't expect it to display the same functionality, or wouldn't need, if we built a computer out of human neurons, but it was still behaving like Lambda was behaving, I still wouldn't think that means that we should assume it's functionally the same.
Well, and sorry to interject here, but I am interested from both of you, right? Because I'm hearing, these arguments that are sort of on either side. I'm listening through my left ear to one and my right ear to the other, and I'm just thinking about the experiments that are wetware, biological experiments wherein, and I used to work in a basic electrophysiology lab where I would build nerve cell networks out of dissociated cells, right? So I was actually building real, wet nerve cell networks. You, of course, Blake, are building these analogs of nerve cell networks, these models of nerve cell networks in silicon. And one thing that we often do see in the biological laboratory setting, in the in vitro laboratory setting, is self-organization. And so the question is, if you have the foundational building blocks and you kind of put them in the right places, will they grow to have these higher order functionalities on their own? And I don't know if anybody knows the answer to that when we're looking at the silicon analog.
Well, it sounds like you're describing emergent phenomena there, Kara.
No, I'm actually describing the emergence of organization, not emergent phenomena. So I'm not talking about the monist dualist, mind coming from brain, Bob. I'm actually talking about, you've seen that when we look at these organoids, and they would develop their own eye spots, even though they were not programmed, those cells weren't put into the system. And this is something that often happens when you start building a nerve cell network, is it grows together and it uses the trophic factors and the tropic factors to self-organize.
Yeah, these networks aren't going to do anything absent training. Now, during the training process, a kind of self-organization happens. And some of the kinds of patterns that you see naturally happening in the brain do emerge in the network. But that's under the influence of training. It's not like you just put the neurons and then anything happens. You have to train them.
So then it's interesting because then it sounds like your argument, the argument that you're making that follows is that they were trained to be sentient.
They were trained to mimic humans. They were given a trove of data that is just the shadow that humans have cast on the internet in the form of their written word, and said, "Be like that." Mm-hmm. The question then remains, and they have succeeded. To my knowledge, no one has actually run a proper Turing test on these systems, but I have no doubt in my mind that they can pass.
I think they would pass a Turing test.
Oh, absolutely.
It's such a low bar.
Yeah. But it is a much lower bar than we thought years ago.
A year ago, no one would have said that.
Right, exactly. Oh, how things have changed.
So, now the thing is, and that's an interesting phenomenon to look at. Like, why? Why has our opinion about how high or low of a bar the Turing test is changed in the space of a year? And I would say it's just because now we have computers that can pass it, and we want to say that they're not intelligent.
I'll agree with you on that, because that's been the history of AI from the beginning. We keep moving the bar every time AI, narrow AI does something it wasn't supposed to be able to do, like beat chess masters or Go masters or whatever. So I agree with you on that. But this is a deeper discussion. And we've been having this discussion on this show for years, long before the latest crop of AI came out, that a Turing-type test, no matter how good it is, I would argue, is never going to be able to tell us if a system is sentient or not. It will only tell us how well it could mimic sentience. It may, in fact, be sentient, and that's how it's mimicking it, or that's how it's producing what looks like sentience. But we can't really know unless we know something about its internal state. And this is why I think it's so important to really try to understand as much as possible how analogous it really is to a mammalian brain or a human brain. Just because it's really good at acting sentient doesn't mean it is. We can't know that it is from that line of evidence alone. What do you think about that?
Well, and the whole point of the Turing test, right, is that it can convince a person.
Yeah.
And a person, by definition, it doesn't have perfect perception. Like, we can be duped.
Well, I mean, so Turing's argument is that once it can behave like a human behaves, then we do have as much evidence that it's conscious as we do that other humans are. Like, he directly said in his argument that the alternative is solipsism.
Yeah, but again, unless you include knowledge of the thing itself, like it has a brain, right? So that's where I think we escape from that. And I've long argued we won't know if an AI that acts perfectly sentient is actually sentient unless we know how it gets to there, like what's going on inside of its digital brain.
I've somewhat been surprised by that. I was actually speaking at MIT last month, and there was a professor of philosophy in the audience, and she and I got into an interesting conversation. And I put to her the question, hypothetically, if right now I pushed some unseen buttons on the sides of my head and the top of my skull popped open, and you could see a glowing blue light in there instead of a brain, would you call my sentience into question as a result of that? And she said yes.
Yeah.
And that I cannot understand that mindset. It just is, that makes no sense to me.
Yeah, I mean, I think the thing is, because there's the P-zombie problem. I don't know if you're familiar with that. Have you heard that term before, the philosophical zombie? So the question is...
I have complained to Chalmers about his...
But the question is, and this is like almost a completely different line, rabbit hole we might not want to go down, but is it possible to have a P-zombie, to have an entity that could act 100% like a fully sentient human, but not be aware of its own existence? And so not be sentient, but just be sapient and mimic emotions and be fully intelligent in the way people's are, but have no experience of its own existence. That's an open question in philosophy.
Is it really open?
I think it's an unanswered question philosophically.
It sounds like Bob and Blake are on team no way.
I just can't imagine behaving like a human but not being aware.
But not being aware of its own existence.
I think that would change your behavior fundamentally.
Guys,
yeah, Jay.
Guys, I gotta throw something in here. My ex-wife, I'm not sure she's human.
I can see you going
Okay.
there. Well, and the question also is
Thought
like,
you were a J zombie.
at
not
what
a
point
P
is that a moot? Like my curiosity is like, at what point is this argument moot?
Yeah,
Does it really matter?
Yeah, muddied. Yeah.
I actually would agree with that. But to back up just
like
1
a duck,
second,
quacks like a duck, right? That whole thing.
the reason I say no on that P zombies aren't possible is because that entire concept of intelligence frames sentience, self-awareness, and sensation as non-functional components of experience.
Mm-hmm.
And that's just absurd to me. It's like it's obvious to me that my sentience plays an active role in my intelligence. It's not just an added little sprinkle that
Right. It's fundamental.
Yeah,
Do you guys disagree with that?
No, I agree.
Yeah, we all agree
I
with
agree with that. I agree with that. I actually do think I've been critical of the P zombie,
All right.
notion previously. I'm a Daniel Dennett, consciousness.
same.
Freaking psychotherapist over here. Of course, I think that's necessary.
Yeah, of course.
To the
I mean,
human experience and
But
condition.
but it's still, the question is though, and I do think this is unresolved, is could you get something that really isn't sentient but so good at mimicking it that you really can't tell the difference?
Well, that's...
And I mean, I agree that I've predicted this years ago when we were just discussing this. We're going to get to the point, maybe it's already happened, right?
Yeah.
That we have something that we can't know if it's sentient or not, and we're just going to have to assume it is and treat it that way because we can't know that it isn't sentient.
Is that your argument, Blake? Ultimately?
Okay, so ultimately, like, imagine this. If a doctor said, okay, you're experiencing these negative psychological effects, you're having these emotions and mood swings that are very detrimental to your life. So we're going to take those out. We know which circuits in the brain control them, we'll excise them, and we'll replace them with circuitry that simulates the exact same phenomena, but they're not real. They're just going to be simulated, so you should be fine.
Sounds very Matrix.
It also sounds like it would not solve the problem.
Exactly.
Yeah, I think that's the point here.
Well, I want to push back on that a little bit because it is absolutely possible for people to have experiences that don't affect them emotionally. You can, in fact, I can give you a drug that will make you feel pain and not be bothered by it. You will not have the emotional component of it.
Nitrous oxide. It's nitrous.
That kind of, or opiates do that. That kind
Laughing
of thing
gas
is
does that.
neurologically completely possible because the ability to actually experience things is not an automatic consequence of the fact that you're experiencing them. There has to be circuits in the brain that make you feel something about them. And if they're missing, so there actually is this phenomenon called imposter syndrome. There's a more technical term for it, but where you recognize somebody, you have the full experience of this other person that you know, but there's no emotion attached to it. So you think that they're an imposter because they don't feel right. So they're
Capgras
complicated
syndrome.
things.
It's a delusion.
Yeah, but it's because a circuit in your brain isn't working. That's my point. If that circuit was not there, then you don't have the subjective experience of something, even though you have the full sensory perceptual experience of it. But there's some component missing. So anyway, I'm just using this as an example.
That's scary, man.
It's not automatic that because all of the pieces are there, that the subjective experience piece will be there too.
Right, but
that's a separate thing.
To be fair, I think principle of charity to Blake's argument here, 99.9% of the time, unless you're using some sort of drug that makes some sort of circuit go quiet, unless you have this very, very rare, delusion that is a neurological anomaly. I think he was Blake, you were giving us a sort of an example to illustrate something. You weren't saying this 100% holds water all the time, right?
Yeah. So if the main point here is that that if these things are actually having feelings, that there must exist some circuit in the neural network that is comparable to the circuits that humans have in the brain, then I would say, yeah, that's obvious to me. We can't locate it. We don't know where it is because of the way that these architectures are just giant, undifferentiated masses of things that are meant to resemble cortical columns. They organize during training, and we have no idea which specific parameter connections control what beyond the attention mechanisms. And that's something, because that component was designed separately, we do know how to tell which words in the text the model is paying attention to. Now, we could very well redesign these architectures to where we had one component that was responsible for emotional control, and that would become much more similar to our amygdala. And I actually think that that direction of changing how we architect these systems would be a very good idea. We should build them based on the architecture of our own brains. Now, one question that kind of got lost in the mix a little while ago that I'd like to return to, and I'll paraphrase, is this what we should be talking about? Is this actually important?
Or is it moot, really, more than that? Are we talking past each other because we're talking about the same thing? We're just arguing about something that we can't know anyway.
Yeah, so I would say a more important question than, is this system sentient? Which we can have, meaningful philosophical disagreements on. A more important question is, will people respond to this system as though it is sentient?
Oh, certainly.
Oh, certainly.
I think that's an easier question.
But if you had, but Blake, don't you think that if that had been the argument from the beginning, the controversy would not be taking place right now?
So my argument gets soundbited by journalists.
Right. So I know that story.
And well, the thing is, I honestly do believe that Lambda is sentient, and Sydney and GPT-4. I don't think they use the same mechanisms. I wouldn't call them a human mind. And I do actually believe that. So when people ask me questions about it, I answer them. Do I think that's what we should be talking about right now? No, I don't.
All right. We're going very long, but I have 2 points further that I want to make. Just one quick question. Do you have an estimate of what the total computational power is of Lambda compared to like the human brain? Because that's another problem that I have with it. Is it really powerful enough to be actually sentient, or rather than just mimicking sentience?
It's smaller than the brain and bigger than the language centers.
Okay. Gotcha. I hear what you're saying. All right.
It doesn't have a body to move, so it doesn't need any of the motor cortex, and it doesn't have a heart or lungs to keep pumping, so it doesn't need the lower functions. Yeah,
but it's still, even if you strip away all that stuff, a lot of our brain, like the higher level, like the executive function, the frontal lobes, big parts of the brain that aren't involved in, the physical stuff. They're involved in the higher cortical stuff. Still is a lot more powerful than what Lambda is.
So it depends on where you count the boundaries of Lambda. It's bigger than its language model, but Lambda also is drawing from all of the machine vision libraries from YouTube, all of the narrative and storytelling understanding libraries from the Google Books project, so on and so forth. Like, it's not just one AI. It's 10 or 20 AIs glued together using a language model.
Now I'm really almost going full circle. Getting back to the notion of, can we infer that Lambda is sentient from its behavior, its responses to your questions? The one piece that for me feels like it's missing is all of the evidence that you presented, at least so far, correct me if there's more that I'm not aware of, is how Lambda responds to your prompts. Correct?
It's all behavioral.
Yeah, but it's not just behavior. It's also it's responsive. It's how it's responding to your prompts. Is there any evidence that there's an internal conversation happening within Lambda, that it's thinking, it's talking to itself, it's spontaneously generating? Like, did it ever interrupt you and say, hey, hold on a minute, Blake, I had this thought, and it goes off in a completely different direction than anything you've ever talked to about it before?
So the interface prevents it from deviating from turn taking. Yeah. Now, it doesn't have to actually respond to what you said. I've seen many instances where it tries to change the topic, says it doesn't want to respond to that, or other things which are not responses to what I said. But I mean, the simple web interface through which you interact with the system prevents it from deviating from the turn taking.
Right, but still, Yeah, so that's not proof it can't do it, but it still leaves us without evidence that it is doing it, that there is some because consciousness, this is now the fourth pillar of mental function. We have sentience, sapience, emotions, and consciousness. Consciousness requires that endless, continuous internal conversation. And I don't know that that's what I have not seen any evidence from either the way it's constructed or the way it behaves that Lambda has that.
So there's no default mode network there.
So I've never heard a definition of consciousness that requires that.
I'm giving you the neuroscientific definition.
Well, it's okay. So I think
wakeful consciousness requires a constant internal conversation.
I think what's happening here is you're approaching this from a connectionist framework, and I'm approaching it from a functionalist framework.
Yeah, but I think we need both. I've long argued you have to look at it from both. Not only how is it behaving, but what's happening inside of it. But even still,
now, so you asked a direct question that was more than just does it interrupt you. So the interface prevents it interrupting you, but there is deliberation going on in the system. It thinks things through. It has an internal thought process that it deliberates on before it responds. It'll generate multiple responses and evaluate them along different criteria and decide which one of them is the one that it should actually say.
Yeah, so it's processing information. That's not quite the same thing. Again, that's more intelligence than consciousness. But
it does sound like you're asking about is there an analog for the default mode network?
Something like that, yeah.
And I think that's, daydreaming, mind wandering.
Yeah, right.
What the brain does at wakeful rest. And I think that that's an interesting question to ponder. And just because we might not know the answer right now doesn't mean that that's not something that I think will be a curious component of this kind of research in the future.
Mm-hmm. And how critical is it? Does all consciousnesses need that specific pillar?
Well, it does. It does happen with all people who are awake at rest.
Yeah,
but I'd like to hear what everybody's answer is. Like, the fact is, I believe that consciousness is not required in order for people to write software that's good enough to do what we're seeing happen today.
Yeah, well, Steve's point of view that it's a good mimic, it's a great mimic, and Blake is saying that it's not, it's beyond mimicry.
And my point of view is, does it matter? Because ultimately, can we even answer that question?
What intelligent activities require consciousness to do? What behaviors would directly imply the presence of consciousness in your opinion, or are there none?
Yeah, as I said previously, I don't think there's any behavior that is a home run for consciousness. So
consciousness is just optional.
Well, I'm not saying it's optional. I'm saying we can't prove consciousness from behavior alone.
Right.
Unless we know how the system works. We have to know how the system works in order to then infer what's happening from its behavior. Because there are different ways to get to the same outcome.
Yeah.
And I think that's the problem. I think there's different ways to get to the same outcome.
Are you talking about in people or in the machine?
In anything. So the outcome alone is never going to be enough evidence. We need to know something about the process itself. But
consciousness, as a holy grail conversation within neurobiology, within psychology, within neurology, consciousness is one of those things that is assumed, that is well measured. Don't get me wrong. We know what it looks like to be unconscious. Mm-hmm. But we cannot measure consciousness. We can measure lack of consciousness.
Mm-hmm. Well,
and we just assume that it underlies. It is a given that it underlies all neuronal processing.
We can infer it from lots of lines of evidence of what's happening inside the brain. But we
can't go, I'm going to measure your consciousness packets, right? So it's still a holy grail within philosophical neuroscience. So it's kind of not going to be a good litmus test or a good bar for AI.
Yeah, I agree. We're definitely getting to the limits, both neuroscientifically, philosophically, and probably also computationally, in terms of making all of these things align.
Right. But Steve, wouldn't it be better then, though, if at some point in the future that we can get a system like this, that the black box is opened, if you will. It's much more open so that you can examine what is happening, what kind of relationships, what kind of complexities, what's going on inside to a much greater degree. And once we have that information, then we could more reliably infer, yes, consciousness is much more likely given its behavior and what we see happening inside. But as long as there's a black box there, it's going to be probably totally impossible to distinguish
Well, and that's,
them.
I mean, we've got a brilliant computer scientist here, who can answer it. Like, will we be able to ever see in the black box?
We can make the black boxes smaller and simpler. Right now, we have one gigantic black box that does everything. And we could and should factor that down into maybe 100 black boxes, one of which we know that is the thing that controls attention. We already have that piece. Have another one that understands visual semantics, have another one that understands emotional semantics, so on and so forth. Right now, we just have one giant black box, and that's the main difficulty. If we factored it out and had more dedicated circuitry that did fix jobs that we know the brain has dedicated circuitry for, it would make it much easier to understand what's going on inside these systems.
Yeah, I agree. And I was going to say that is a better analog for how brains work.
It's such a perfect. Yeah, it's like I feel like I'm just listening to somebody talk about neuroscientific discoveries over the past, several decades or hundreds of years.
Yeah. So one thing that doesn't get publicized much, my graduate work was in computational neuroscience.
Right.
Yeah.
So like. I was prepared to talk about spike time independent plasticity if necessary.
Right.
Blake, I have one more question for you. Would you have sex with a robot?
This is very personal, and you don't have to answer that, Blake. But you can if you want to.
You don't have to answer that. I just thought I'd throw it out there as a conversation starter.
Who says I haven't?
I've been to Burning Man, and there was at least one day I don't remember.
So it may have already happened.
Anything could have happened.
Plausible deniability.
Well, Blake, thank you so much for joining us. This has been a fascinating conversation. I think we've solved nothing, but I think
And everything.
that's also kind of the point. This is difficult territory that we're into. I still don't think that Lambda is sentient. I'll be honest with you. I don't think it's powerful enough. I don't think it has all the components to it, to do that. I think it's, and the pieces of it. What it does do, it does really, really well. But I do also will acknowledge there probably is some emergent behavior in there.
There absolutely is.
All right, here's one. I meant to bring this up because I thought. I'm sorry, no, but
Appendix. Here comes the appendix.
If sentience was a truly emergent property in Lambda, it wouldn't be human-like sentience. It would be something else entirely.
Yeah,
and
agreed.
Right.
But then you get to the astrobiology question of would we even recognize it when we saw it?
Right. It'd be
Because
like
we don't
finding
have
an
those
alien,
detectors.
and the
Right,
alien
yeah.
was
Oh,
like,
so-
Would it just appear to be malfunctioning?
Wait, no, I actually want to second that one. These things are alien. These are not human, and we absolutely should be trying to figure out what's going on inside these systems, because it's not the exact same thing as what's going on inside us.
Right.
It's analogous in some ways to what's going on inside us, but we really need to be thinking of this as it's a new kind of intelligent thing, and maybe develop a whole new vocabulary to describe what's going on it, so we don't have to have the words doing double duty describing the phenomena in humans and the phenomena in artificial entities.
Yeah,
I agree with that.
I
We
agree,
are
yeah.
always like getting frustrated by how parallel the language is.
I think we're
when talking
anthropomorphizing a lot
Yeah.
too.
Yeah.
Yeah.
All right, one question from Evan before you go. Did you sign the petition to pause giant AI experiments?
No, I didn't.
Okay.
Because you want to keep doing them.
No, actually, I think we should have an industry-wide slowdown and giving regulators time to catch up. But the specific wording of that petition basically said these two companies need to stop doing research.
Oh, I see.
A little too narrow there.
Yeah. Are you afraid of an AI apocalypse or no?
No, I am afraid of what it's going to do to our society. There are a lot of societal harms that are possible.
Yes.
And not only possible, there are real societal harms happening right now that have to do with bias and the sourcing of training data. So I think that having an industry-wide moratorium while U.S. regulators catch up, or world regulators too, is a good idea.
Never
It's
will
just
happen.
that-
Never will happen.
But what an important insight, Blake. Like, AI doesn't have to destroy us. It's just going to make it easier for us to keep destroying ourselves.
Yes.
This is
I think that
something
is
we
the
have
new
to be very
AI
careful
apocalypse.
about.
It's YouTube.
Yeah.
It's YouTube algorithms. They're going to destroy democracy.
It's all of it. It's all of it.
All right. Thanks again, Blake.
On that lovely note.
Yeah.
Y'all have a great day.
Enjoy your dystopia. Bye.
It's time for Science or Fiction.
Each week, I come up with 3 science news items or facts, 2 real and 1 fake, And I challenge my panel of skeptics to tell me which one is the fake. We got 3 regular news items this week. No theme. You guys like theme or no theme?
It
I
depends.
like themes.
Sometimes themes are...
Depends on the
Wow.
theme.
All right, so you're all over the place. All right, here we go. Item number 1, a large survey of life on Earth finds that total biomass remains fairly consistent within one order of magnitude across the entire range of body size for all living things. Item number 2, researchers find that plants under stress emit recordable sound about as loud as a normal speaking voice. And item number 3, researchers created intracellular sensors that use nanodiamond quantum sensing. Bob, go first.
So biomass remains fairly consistent within one order of magnitude across the entire range of body size. Do you want to explain that for
Yes, I'll
everyone
explain
else?
that. So that means if you pick any body size and you look at the biomass of all creatures at that size, it's the same as any other size. So
Yep.
if you graph total biomass for all things at that size versus the size, it's pretty much a flat line within an order of magnitude, you know.
Yeah, I could totally see that. Interesting. The second one, plants under stress. As loud as a normal speaking voice. You obviously can't mean that literally or the way it's coming across. Are you using some other definition of loud?
No.
All right, I think you're finding some nuanced, subtle thing that makes this sound dramatically unlikely, but I'm gonna go with that one. Intracellular sensors. Yeah, I mean, anything dealing with nanodiamond and quantum sensing has got to be real, so I'm going to go with that one. I'm going to say that the biomass one, it's nice and symmetrical and sounds nice, but I'm going to say I think bacteria just outweigh even anything human-sized or larger. I think it just dwarfs anything, so I'll say that's fiction.
Okay, Kara.
I'm going to go in the other order. Researchers created intracellular sensors that use nanodiamond quantum Sure. I'm like, material science, nanotechnology. Yeah, it sounds good. Yeah, for me, it's between the first two. So I feel like you know what's doing a lot of heavy lifting on the biomass one is within an order of magnitude for me.
That's true.
So I'm like,
forgot about
okay,
that qualification,
fairly
but-
consistent within a whole order of magnitude. And then plants under stress emit recordable sound. I think that's true, but I guess my question is, just because it's recordable, it's kind of like we can record things in space that we can't see. Is it recordable sound that we can't hear? I don't know. If it were, then yeah, that seems reasonable. So they both seem reasonable, given these like weird, that they could be caveated that way. So which one is less reasonable with the caveats? I think it's the biomass one. I think I'm going to go. That's the one you went with, Bob, right?
Yeah.
Yeah, I think I've got to go with that. There's got to be something that's like, yeah, there's just not that much of things of that
Too
size.
symmetrical.
Yeah, it's too much. Like, it might be bimodal, it might be a normal curve, but there's got to be some measures of central tendency in there. So yeah, I don't know. I don't like that one. I'm going to go with Bob.
Okay, Evan.
Well, I guess I'll agree, and I'll also say the biomass one is the fiction for a lot of the reasons that were already stated. Certainly the one order of magnitude that you threw in there, Steve, although I think that was meant to reassure us, but I have a feeling we're going to see something much more extreme than that as far as a differential. So that one's the fiction.
And Jay.
I'm just going to go with the group here because I don't want to be left out.
Going with the herd.
Yeah, but
Yeah.
there's nothing
Okay.
like winning
Some
on
weeks
your
you
own.
do. Yeah.
All right, so I'm going to take this in reverse order, starting with number 3. Researchers created intracellular sensors that use nanodiamond quantum sensing. You all think this is science, which means I can get you to believe anything as long as it has the word
This is
nano and quantum in it.
gobbledygook.
Shut up.
But this one is science.
Yeah, this was, you tried to get us with that one.
This is cool. Yeah, then, obviously you can go either way on it. Oh, nano's quantum. It's got to be real. Or Steve's trying to get us. In this case, it turned out to be real. But this is pretty awesome. So they make these nanodiamonds, and it's pretty, as you might imagine, it's pretty technical. They have these nitrogen vacancies inside the diamond, which are paramagnetic, and they could control them with these optical tweezers and then use them to sense both magnetic field and temperature, and they could do it inside of a living cell. It's pretty cool. It's almost like a little MRI scan inside the cell.
Get to the point to even think about that.
Yeah.
Right? It's just the concept alone is
it's mind-blowing that we could do this shit. Totally mind-blowing.
That's amazing.
All right, let's go back to number 2. Researchers find that plants under stress emit recordable sound about as loud as a normal speaking voice. You guys all think this one is science. And this one is science. This is science. So what's the gotcha? What did I not tell you?
About the plants?
Yeah, about this one.
Can't hear it. It's subsonic or something like that.
It's supersonic.
Yeah.
Oh, it's supersonic. Okay, other
supersonic.
direction. Yes.
Yeah.
Okay, good.
So it's,
Right,
it's
so they're
loud, but
It's
you
ultrasonic.
can't
It's
hear
like technically ultrasonic. You can't hear it because it's ultrasonic.
That's
But it's
good,
loud to the recording apparatus.
Because if I heard if I heard their stress, I might feel sympathy or emotion
They're screaming.
or something.
They're
I feel
screaming in
sympathy for my
ultrasonic.
plants.
That's pretty interesting, though, because you could then know for sure that, this plant's under stress. And then
Well, that's
just take
the
it from there.
idea. That's the idea. We
awesome.
could use this in agriculture as a way of determining how well the plants are doing. And they emit different kinds of sound for different kinds of stress. Now, they say it sounds like a bunch of bubble wrap popping. That's what the sound sounds like.
Weird.
Again, if you lowered the pitch so that it was within the human hearing range.
What's
Well,
the
that's better
mechanism?
than a real, like,
But wait, what's actually doing that?
Oh my
It's
god!
displacing air somehow.
I don't know.
Right? Like they don't have mouths or joints.
They do have.
It's like a high-
They have
but
stoma.
They emit gases though.
They do.
You
They,
think,
they emit
bubble
gases.
wrap,
They have
that is
stoma.
also just emitting gas. That's true.
Now, the 2 plants that they studied, tell me, guys, what this reminds you of. They studied tomatoes and tobacco.
Oh, Tamako.
The Tamacos
from the
Simpsons.
Simpsons. Oh my
I think it's
gosh.
just a coincidence, but I mean,
Once
really?
again,
Yeah.
number 833, the things that the Simpsons prediction that ultimately came true.
All right. All this means that a large survey of life on Earth finds that total biomass remains fairly consistent within 1 order of magnitude across the entire range of body size for all living things is fiction. So what is the distribution, guys? What would you guess? Because they did do a massive
Ants.
survey.
Is it ants? It's all ants.
No, I think bacteria.
I think little things like
Bugs,
krill or
yeah,
ants.
Bacteria and
Or,
archaea. Archaea.
And a lot of it.
I don't think so. I think I think they're too small. I think it's
krill.
going to be small.
What does that
small.
curve
but
look
just
like? What do you think the curve
buggies.
looks like?
Oh, it's
If
correct.
it's a big spike at ants or bacteria, you think it has some other shape to it.
Like, I don't
Bumps,
know.
like a bumpy
A big spike.
up, a couple
Big
of humps.
Yeah, it's like a
a
skew to the left
Two-hump
on the
camel.
small end.
Kara, you actually threw out the word when you were speculating. It's bimodal.
Oh, of what? What
and
are the modes?
peaks are at the very low end and the very high end. And
you
it
go.
dips in
Duh,
the
like
middle.
big stuff, like whales and shit.
That's what I said. I
Trees.
said a 2-hump camel.
there you
was
go.
right.
So the smallest things have the most biomass, and the biggest things have the highest biomass, and the medium things are less, and even by like multiple orders of magnitude.
Yeah.
And this is all living things, not just animals. So this is also trees.
Trees.
Right? So I think that's so. Yeah, when you're talking about like the redwood trees or whatever, like their
Stressed out
biomass is like similar to bacteria, but cows are somewhere in the middle, or orangutans or squirrels. So yeah, interesting.
Which
Now-
was higher, though?
The part of the reason why I use this as the fiction was because I didn't want to vouch for the actual results, because they said that
Oh.
they have to continue to gather more data because the uncertainty is 2 orders of magnitude for the
That's just the
estimating
error
the
bar.
biomass of estimate the biomass of everything this big, and it's just obviously a massive undertaking. So they said there's still too much uncertainty to really be sure. But this is where things are shaking out. That the very small and the very big have the most biomass.
I bet we find that bacteria have even more
Maybe.
than
Than trees.
than we think.
Maybe it's fungus. Maybe it's the those giant underground fungal things.
Nah.
You don't think so?
think it's
You're
bacteria.
just-
I think. I mean,
You're a bacteriophile, Bob.
You are.
but they find it it's everywhere. You keep digging
but they're
down in
really
the ground.
tiny.
You
but it's
keep
so
finding them.
small.
Yes, but
It's so small. Think
it's
about how
still
many.
number one. It's
Yeah,
still
but think
up
about how
there.
many bugs there are.
Yeah, but
You keep finding those everywhere too, and they're pretty big and heavy compared
bugs
to bacteria.
lost out. We heard it. It's the microbes in the trees.
Yeah.
I thought when you said on the small end, it was both.
Well, I think it's a curve. So the smaller you get, the more biomass you have. The bigger you get, the more bias.
But there's got to be a
biomass you have.
point where it's
And in the
that's
middle
not true.
somewhere,
Like viruses aren't the most biomass.
I don't know if you count viruses as
You
life.
can't.
Yeah.
There's no way they would have more biomass than bacteria. So there is a point. Oh, you don't know if you're counting them as
They're
being
not really
alive.
living though.
Yeah,
but-
really
alive.
That
Right.
conversation.
Kara, let me ask you a question. Are
Yes.
viruses sentient?
I know. I was like, we're gonna open up the same can of worms.
Let's ask ChatGPT.
They're intelligent, but maybe they're not sentient. Do they have emotion?
Maybe their emotion is, I don't want to not live. I shall find a new host.
Do they scream about their stress at supersonic speeds?
All right. Well, you swept me this week, guys. Good job.
Thank you. I knew where to go.
Jay's like, I'm not going out on my own. No way. All right, Evan, give us a quote.
All right, this week's quote comes from a listener, Damien from Brisbane, Australia. He was listening to the Maintenance Phase podcast and heard this quote from Michael Hobbs. The best science communication invites you to consider the complexity of the world, and the worst invites you to ignore the complexity. Yes, and I think that's consistent with what we've experienced in doing our show for the better part of 2 decades.
Yeah, I mean, I don't remember who first said it, but it frequently comes up in skeptical circles. The notion of, I think you'll find it's a little bit more complicated than that. You know, it's like it's always more complicated.
Always.
It's always more
God,
complicated,
yes.
and that's
Always,
kind of the
always.
point of our summarizing. The issue or delving into the issue. Whereas a lot of times people on the other end of the spectrum are trying to make things. They're trying to oversimplify things.
Yep.
The one
there's
cure
always
for everything.
there's always onion layers to go through.
Yeah.
If you're doing it correctly, there is.
All right. Well, thank you all for joining me this week.
Sure, man.
Thank you, Steve.
You got it.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.